All right, guys, so here we have a couple points in an equation, and we have to determine if it's in, on, or outside of the circle. And so remember, the way we're going to do this is, again, by using the equation. But we have to kind of acknowledge one really important thing, which is if I take this side of the equation, that's essentially a distance. And that's the distance between the point that we have and the center of our circle. And we're really comparing that to the right-hand side, which is essentially our radius. Okay, now it's really our radius squared value, but that's okay because we tend to be able to compare squared values just as well as we can compare non-squared values. And remember, if the calculated distance is less than the radius, it's inside the circle. If it's the same as the radius, it's on the circle. And if it's greater than the radius, that distance pushes that point outside the circle. Either way, we're definitely going to start with the equation no matter what. So let's write this thing. Okay, but we actually know a bunch of the pieces, right? And so we know that x, the x that we're testing, okay, is going to be 6. The h value is going to be 5 because we have the, we should probably write that point. The center, okay, is going to be 5, 1. Okay, so the h is going to be 5. Okay, going back to the y value, what are we testing? Yeah, it's going to be 0. Subtract off the k value, which is going to be our 1. And we're testing that against the known r squared value of 9. Okay, and I'm getting that right from my equation, right? So let's simplify. So 6 minus 5 is 1. 0 minus 1 is negative 1. Okay, so 1 plus 1 is equal to 9, or 2 is equal to 9. Well, they're not actually equal. And here's where we have to make that determination. And so the distance, 2, okay, is actually going to be less than the calculated radius, or radius squared value of 9. And so this point is going to lie inside the circle. Okay, does that ask us to explain? No, it just says inside, on, or outside. But that's the reason why. It's because the distance we calculated on the left with the x minus h squared and y minus k squared is less than the radius squared value. So that means the distance between the center and the point 60 is less than the radius of 3. Therefore, it's going to be inside the circle. And we can use that as a template. In fact, we can even start just with the equation itself. And so we don't have to go all the way back to the general equation even. Because this is already kind of pre-substituted for us, right? And so all we really have to do is substitute in this x and y value. Okay, so we have minus 5. Okay, so we have 8 here, and we have 2 there. Okay, so that'll give us 3 squared plus 1 squared is equal to 9. So that'll be 9 plus 1 is equal to 9, and so it'll give us 10, which is not the same as 9. But in this case, the calculated distance of 10 is less than the radius squared distance of 9, and so this is going to actually be outside. I think I said less than, I meant greater than, and so it's going to be outside the circle. Okay, so it looks like we have a repeat of what we just did, which I think is fine. So we have a new equation though, so let's start with x minus 2, y plus 3 is equal to 4. The new substituted value is xy. Okay, so let's substitute those values in. So the xy is going to be 0, 0. So we're actually checking against the origin. Okay, so that's negative 2 squared plus 3 squared is equal to 4 squared. Well, that by itself is 4. Okay, so we have 13 and 16 not equal, but we have a smaller value for the calculated distance between the center and the point, and so this is going to be inside the circle. All right, so x minus 2, y plus 3 is equal to 4. And the point we're checking is going to be 2 comma negative 5. So let's get that substituted in for our x and y. Okay, and remember, when we do the substitution, so 2 and -5, it essentially turns the left-hand side of this equation into a distance calculation, because that is essentially a distance formula, just not square rooted. So when we find this to be 0, that'd be -2 squared. And so we have 4 is equal to 4. And so even though neither one represents a distance or a radius, they're both the squared versions of those. Certainly if the squared radius and the squared distance are the same, if I were to square root them, they'd be the same. And since they're equal, this is going to be on the circle. Okay, and so I'm going to stop that video there. I'm going to make, of course, I'll make videos out of the next 2 parts, but I'm going to shorten it so you can kind of choose how much you want to watch. So I'll see you guys in the next